Welcome to Unit 5, Lesson 5, Changes over Rational Intervals. Let's look at how exponential function changes when the input changes by a fractional amount. So this is going to be a little bit different than what we did. We've known how to change, or we've learned in the last 3 lessons, starting from lesson 2, 3, and 4, how to change the input. But what if the interval is not a full 1? Okay. Consider the exponential function. All right, so by what factor does h increase when the exponent x increases by 1? So if we were to say, here is our term, our a is obviously 1, and our b has the exponential next to it. So if we take 4 to the x, increase means plus 1, that equals 4 to the 1 times 4 to the x. So we can see our factor increasing by 4. Now, what does an increase by 2 mean? An increase of 2 means 4 to the x plus 2, which equals 4 squared times 4 to the x. And now our factor is increasing by 16. Factor. The factor is just the b part, so we're only looking at the b part. We're not worried about the a. Now, 4 to the x plus 0.5, and we know that 0.5 equals 1/2. So now, this equals 4 to the x times 4 to the 0.5, or 4 to the 1/2, which equals the square root of 4, because the denominator is the index on a radical and the numerator is the exponent. This equals 4 to the x times 2. I kind of wrote that one backwards from the other ones, but you get the gist, you understand. So the factor is changing in each one because the exponent is increasing or decreasing. Okay, now let's look carefully at this chart so that we can understand what's going on or analyze what's going on here. So here is an interval of 1, which is actually 2 jumps. And our first interval is half a jump. So half a jump, half a jump, half a jump. Then it jumps another half. Then it jumps a full 1. You have to pay attention to the information on your table. So without reading the questions, we're given the numbers, we have to write our exponential function. So we have a here. A is where we start when x is 0. That's our a. Now, how do we calculate b? We're going to take one full jump because we don't have a number at a half. And so we're going to take 13,600 and divide it by 16,000. And that is going to give us 0.85. So this is the value left, which means 85% of the value is left, which means the machine is losing 15%, because 16,000 is 100. You lose X%, and that will give you your depreciation. If we solve for X, we'll see that X equals 15, because 15 is 85 away from 100, or that's the difference between X and 100. So we're losing 15% per year. But now we have half. So let us write our equation now. So f of x, where x stands for 1 whole year, equals 16,000 times 0.85 to the x power, where x stands for years. 1 year. And so what we've done previously was we've taken this equation and we've done 16,000, 0.85. I want to take x over 2 to get our in-between values, because there are 2 jumps that go from 0 to 1. So if we divide by 2, that will give us a half. Okay, so you can see we get 14,751 and 12 539, just by reading the tables. This is why we do what we do. So now let us answer question number 3. Observe the values in the table by what factor? So every 1 year, from 1 year to 2 years, from 1 year to 2 years, well, 2 minus 1 is 1, so that's a 1 year period. The factor is 0.85 to the 1. And then from 1.5, from 1/2 year to 1.5 years, that's still the same thing. It's 0.85 to the 1. So the time frame is the same. The factor is the same, 0.85. Okay, now look at this. We want every half-year period here and 1.5. So what's the factor? Our B is still 0.85, but now we're going to raise this to the half power, which is about 0.92. So that's the factor for every half year, is 0.92. So I'm not going to worry about number 4, but basically you take your 0.85 to the Q plus 0.5, just like in the warm-up, which equals 0.85 Q times 0.85 to the 0.5 of the 1/2 power. If Q is 1, just multiply them together. I don't know why they wanted to do that, but